Good evening and welcome to Tinkering with Atkelar. In the last episode, I took care of the cosmetics and basic needs of this HP 9825A here. Be sure to watch it first for details on how I ended up here. Now, part 2. Recapping. The only electrolytics on the regular PCBs are tantalums, and they measure fine. The power supply is the only PCB that deserves a few new ones. And while I'm here, also removing the power transistors for some fresh thermal paste. The heatsink has some standoffs as well as insulation pads to the transistors. They did everything they could to keep the heatsink floating. Until they decided to screw it to the grounded transformer case, that is. And here we go. New caps with the highest temperature rating I could get. Add some thermal paste. Fitting the large diode first to hold the spacers in place. And last but not least, the main filter caps. The newer models are slightly smaller again, and I couldn't get axial ones, so I have to improvise again. I reuse the same path for the zip tie again, so they don't flop around too much. Note that the long wires are all at ground level, so they don't need much insulation. They can touch pretty much anything they can reach without issue. And in between recapping, I decided to clean up the wire loom too. I didn't want to wash it, so I rather snipped open the zip ties one by one, cleaned the wires and put on a new tie. That way, it retained its shape and I could clean between the wires. If it weren't for that awful damp smell, I'd probably leave it at the clean the visible side only level. Assembly time! Attaching the ROM covers again. The springs are a bit fiddly. Remounting the system ROM module. Continuing with the fan. As you can see, some of the dust didn't want to come off the rough surface, even with a scrubbing brush and detergent. But at least it smells nowhere near as damp as before. The system ROM slider. OS upgrade with just a pull and push. Eat your heart out, Microsoft. Connecting the transformer outputs to the wire loom again. And adding the transformer case. Careful with the wire routing. And power on with the power supply in place. Checking the outputs. Looks good. No smoke, no loud noises. All voltages within tolerance. Fitting the I/O backplane again. You can add various adapters here, like an HPIB one or a clock module. I'm still looking for some. You know, I like to max out these old devices to make them as useful as possible. Up next, the shield plate for the ROMs. I'm still a bit confused as to why the middle ones are bent over like that, but it seems too nice to be by accident. And the ROM backplane. And now to the main PCB. The CPU is hiding underneath that huge heatsink. You can see it poking through a bit on the underside. Since it's an unobtainium piece of ceramic substrate, I'll leave the heatsink on and just clean around it. The KDP board also has a speaker on it. Before hosing the board down, I'll remove that. The membrane shouldn't get wet. I did find out why some of the keys are not working properly. Seems a few of the pivots broke off. Angry typist? Or just old plastic? The repair with crazy glue didn't work at all, so back to the old heat shaping trick. Especially for those keys where the pivot wasn't even to be found on the inside and I had to replace them with some leftover 3D prints. And now, getting the keys back into place. Some Q-tips as spacers and scotch tape to prevent accidents. Let's go! Doing the keys upside down and backwards took some time. I'm adding the PCB and a pair of screws before I double check the key layout. It would be annoying to have to undo all of the screws again, wouldn't it? Nope, good thing I checked. I had the character portion back to front. Now it's correct. 1, 2, 3. And yes, it is annoying to undo almost all of the screws again. When I was almost done, I realized that one of the keys wouldn't click. Turns out that there was something stuck under the contact spring. Finally, all the screws and all the keys. Time to mount the keyboard again. Whoops! Forgot the insulation sheet. Take 2. Adding the KDP controller board next. Like the CPU, the KDP chip is a one-of-a-kind. I pondered removing it from the socket for a bit of contact cleaner, but it would not move when poking gently, so I left it in here. Aha! The new lines filter arrived. It only almost fits. I need to mill down the outer rim of the socket a smidge. Adding the cover again. Now I got enough parts in place again to put the CPU board in. It takes a bit of wiggling to make sure the zip ties on the wire loom are flat enough to fit underneath. taking care of the tape controller PCB next. It has a set of power transistors on it. These drive the tape motor. Fresh thermal paste, of course. And now, adding the memory PCBs. Note, the base model had a single 8 KB module and there were options. One came with a 16 KB board and the one I have here is option 2, which has one each for 24 KB of RAM. Option 3 existed too, having two 16 KB modules for 32 KB of RAM total, but that overlapped a bit with some of the option ROMs, which then are not compatible anymore. Remember, this is a calculator, not a computer. So 24 KB should be plenty for my purposes. You can check out Curious Mark's video on the T model to see what weird solution HP implemented to have a fully stocked 64 KB RAM version. It's borderline bonkers. Adding the keyboard unit and giving it a quick test. Nothing. The only thing that worked was the shift lock key. And that is wired up via a set of TTL gates only, so no CPU, ROM or RAM needed. Not a good sign. Oh, maybe it's because I forgot to put in the system ROM. Could be. Nope, still nothing. I double and triple checked the power supplies and realized then that the 5V transistor and filter inductor were getting extremely hot. The power supply provides several voltages: plus minus 20V unregulated, plus minus 12V regulated, plus 7 and negative 5V for the CPU, and of course the high current 5V rail. Note that these voltages have different current capabilities, with the negative 5 volt just being a Zener diode without any transistor at all. The other regulated voltages are pretty much linear regulators, with the exception of the 5 volt rail. This one is a buck converter. The transistor, Q3, should provide a train of 20 volt pulses to the inductor, but on my unit, the signal went from 20 volts to negative several hundred volts. Yikes! The output filtering kept the 5 volt rail in check, but the transistor and inductor took quite a beating. The huge diode on the heatsink is supposed to clamp down those negative spikes from the inductor, so let's check it. Nope, that's no longer a diode. Let's get a replacement. Huh? Yikes! Expensive! Oh, but yes, I have found some more reasonably priced ones on eBay. While I'm waiting for these to arrive, I put in some random high-power Schottky I had around. I think I salvaged that from a broken stick welder. Before I start tracking errors in the deeper parts, I wanted to make sure the display is working. The LED matrix chip are still available in smaller numbers, but I have to order them, and I wanted to have them ready when the calculator is finished. So let's breadboard a quick test. Yes, that looks good. All the pixels seem to light up and the bits are making their way through, with the driver transistors driving all of the columns, even though sometimes there seems to be a bit of a burst in my clock. Now, following the signals of the KDP chip around a bit, it seems that it is completely dead. According to what I know about it, it should at least have some activity on the outputs, even without any input from the CPU. My snooping led me to the data bus transceiver chip as a suspect. I desoldered it and gave it a try. Seems to work on all channels and in both directions. Back it goes. In the meantime, the replacement diodes arrived. Let's brush it up a bit and give it a try. And now the tape drive motor. It needs to come off so I can take it to the workshop and remove the shaft from the capstan. I cut a notch into a piece of aluminium angle bar, but since I don't have a fitting punch, I had to resort to abuse a surplus hex key. That was really stuck. Turning off the old capstan. And some neoprene for the new tire. I first drill a hole, slightly undersized for the capstan, and putting that on the lathe to get the outer diameter close. You can't see it here, but there is a small pipe in the chuck as a carrier. Finally, with the tachometer assembly removed, I can now open the motor for a quick checkup. And a good thing I did. The commutator looks good, the brushes also look pretty much new, but the rear ball bearing wouldn't turn. It seems that the axle was rotating inside the bearing. That's not good. The inner race had some rust on the outside, so let's get to the bottom of this. No amount of wiggling would move it. So let's get the snap rings out and look what's behind the shields. Yep, all gunked up, not moving even a tiny bit. It took quite a bit of spray oil and repeated cleaning to finally get it to turn. Getting the bearings to work properly is important. The motor is experiencing quite a bit of side load from the tape cartridge. One of the snap rings sprung away, but the shield will be held in place with the thrust washers, so it should be fine. And after adding the tachometer assembly again and fitting the capstan, time for a test run. Nice! The new rubber sleeve has a bit of run out. With the system still not working at all and running out of ideas, I decided to validate if the CPU had proper contact to all the signals. You recall, it is visible through the PCB and one can even poke some of the data lines for continuity. Most worked fine, but I couldn't quite get a reading from some. So let's double check. And here we go. The CPU is nested inside the heatsink and the pins are making contact to the PCB traces via a zebra strip-like contact strip. As I thought, the thermal paste is bone dry. Giving it a good clean and scraping off a few odd spikes in the heatsink. I'm sure it should be as flat as possible. The CPU itself has some pencil marks on the back. Giving all the contacts a proper clean with contact cleaner. There was quite a layer of dirt coming off. And new thermal paste. The screw positions are slightly offset to make sure that the keyed heatsink and CPU only ever fit in one orientation. Clever. A quick check to see if the CPU makes good contact and if the adjacent pins are not shorted. And attaching the heatsink again. It was nicknamed the cylinder head apparently, and I'm fastening the nuts in a diagonal pattern just like with one of these. I want to avoid straining and possibly cracking that chip. But it still doesn't work. And now to the print head. That clip-on bracket holds a little temperature sensor. Remember that broken strain relief? Yeah, here's why that is very important. These connections are not soldered, they are welded, and the wires are very special and brittle. Bending them even slightly makes them snap off. At least all the contacts are still here on the hybrid. And that's it for part 2. Check in next time for the conclusion of the project. Also, as is common, the pinch roller is in need of a new rubber coating. Coating. Yeah, of course, rubber coating.